Assalamu alaikum. Okay, this is our experiment number 4. In this experiment, we have this belt friction static and dynamic apparatus. As you can see, the basic objective of the experiment is to determine the coefficient of friction between the flat belt and the cast iron pulley here. Like, we have to determine the coefficient between this flat belt and the cast iron pulley down there. Okay, first we can look at the different components of the apparatus. As you can see, the black one on the right hand side, this is basically a spring balance, a normal spring balance to measure the tension in the right hand side in this part of the flat belt, and in the other part the weight applied in this hanger, the down hanger, that's basically of 100 grams, that gives the tension in the left part of the flat belt. And first of all, you can look at the different points or the different holes. These holes basically are there to set the angle of the flat belt. Right now, the angle set here is 90 degree. Okay, so basically, when we mount, when using the L keys, we can basically unlock these two screws. Okay, right now they are set at 90 degree. So if I open these screws and like move this rod at this point, so the belt will be nearly like vertical. So at that position, approximately there will be no touch or the no contact angle of the flat belt with the cast iron pulley. So in that case, the angle will be 0. So if I attach these two, if I attach this rod at this point, so the contact angle of the belt will be 0. At this point, the contact angle will be 30 degree. At this point, 60 degree, 90 degree, 120 degree, 150 degree, and 180 degree. So we can set the angle of contact between the belt and the pulley from 0 to 180 degree. So I'll apply the load at the lower hanger, that will be counted as a T1, and the value of the spring constant, the value of the spring, the black one, will give me the tension in the T2. So using these two values, I'll calculate the coefficient of friction between the cast iron pulley and the flat belt. So looking at the formula, okay, as you can see in this diagram, the right side is the T1, that's the higher tension. T1 is basically the pulling the belt to the left side, and T2 is basically the resisting one. So the impending motion between the belt and the pulley would be towards left. So the relation from the engineering mechanics, we have this relation for the flat belt, and that's only valid for the flat belt. T1 is equal to T2 e raised to power mu beta. T1 is the tension, the pulling tension, and T2 is the resisting tension, and mu is the coefficient of friction between the flat belt and the cast iron pulley or the pulley here, and beta is the contact angle, the angle that the belt makes with the pulley. So that's basically beta, you can see in the diagram, and mu is the coefficient of friction. So we have to basically determine the coefficient of friction. So what I'll do, I'll give the tension T1 by applying the weights. So I know the T1, T2 would be given by the spring balance. So I know the value of the beta, so I can, using this relation, I can calculate the value of the coefficient of friction for the flat belt. So this is for the impending motion. Keep it in mind, okay, if this mu is not given, if the coefficient of friction between the flat belt between the belt and the pulley is lower than this one, then the belt will slippage. Okay, look at the experiment now. I have different weights here. This is a hanger of 50 grams. This one is of 100 grams, the one already mounted. And these are the loads of 5 Newton, and these are different loads of 2 Newton and 1 Newton in different values. So in right here I have the observation table. Beta is the contact angle, and TL is the higher tension, TS is the smaller tension, and TL minus TS would basically give me the value of the difference of the tension between these two, and T chord is the tension applied to slip for the slippage of the belt. So we will look at these parameters. First of all, before starting the experiments, look at the value of the spring constant. Look at the value of the spring. So right now you can see that that's not actually 0. So there is a 0 error. So each reading is basically of 50 grams. So 0, it is 0. The next reading, this one is of 50 gram. The other one on the other side is 100 gram. So again 1, and this size is 150 gram. On the other side 200, and then 250 grams. So there is an error of approximately 350 grams. So first of all, before starting the experiment, we must sure that this value should be set at 0. So by rotating this knob here, I can actually set this value to 0. So it's approximately 0 here. So I'll apply the T1 tension at the lower side of the belt. Okay, I have applied a force of 10 Newton at the bottom hanger. So now I'll basically, what will I have to do? I'll have to apply the torque here, the amount of the torque such that कि स्लिपेज अकर हो जाए. बेसिकली आपने क्या करना है, इतना टॉर्क अप्लाई करना है कि स्लिपेज अकर हो जाए. उस पॉइंट पे हमने क्या करनी है, ये वैल्यू नोट करनी है इन द अदर साइड ऑफ द हैंगर. देखें अभी स्लिपेज नहीं हो रहा, तो दिस इज़ नॉट द T2 बिकॉज ये इम्पेंडिंग मोशन क्रिएट नहीं हो रही. तो हमने क्या करना है, दिस इज़ मोर देन 750. लेकिन जब मैं यहाँ पे बेसिकली क्या करता हूँ, इस रोटेट करवाने की कोशिश करता हूँ स्लिपेज, तो दैट स्मॉलर देन 500. सो ये वैल्यू जो है ना मैंने नोट करनी है. Okay, so I'll apply the weight at this chord. यहाँ पे लोड अप्लाई करना है यहाँ तक कि स्लिपेज अकर करने के लिए, ताकि स्लिपेज हो. यहाँ पे आपको क्या नज़र आ रहा है, 50 ग्राम्स का बेसिकली मैंने हैंगर अटैच कर दिया, लेकिन स्टिल देयर इज़ नो स्लिपेज बिटवीन द बेल्ट एंड द कास्ट आयरन पुली. तो मैं क्या करूँगा, इसके बाद मैं यहाँ पे लोड इंक्रीज करूँगा. This one is of 1 Newton, no slippage. Increasing the load, 2 Newton, no effect. 2 Newton more. The total is 4 Newton. Still there is no movement. Sorry, there is movement, as you can observe. Okay, this is the right value. Okay, T1 आपके पास कितनी है यहाँ पे 10 न्यूटन, और T2 आपके पास कितनी है, approximately 300, 400, 500 and 550. Okay, that's 550 grams. 500 there and the 50 grams this side reading. तो आपके पास जो T2 है वो कितनी है 550 ग्राम्स है और T1 आपके पास कितनी है 10 न्यूटन और दरमियान में जो आपके पास डिफरेंस है जो T कॉर्ड है वो बेसिकली क्या आपके पास 4 न्यूटन है. तो इस पॉइंट पे यूजिंग दिस T1 एंड T2 वी कैन एक्चुअली फाइंड द कोएफिशिएंट ऑफ फ्रिक्शन बिटवीन द बेल्ट एंड द पुली. ओके, यू कैन ऑब्जर्व द स्लिपेज. ओके, सिमिलरली आपने क्या करना है डिफरेंट एंगल्स पे कैलकुलेट कर सकते हैं हम. यहाँ पे 0 पे 30 पे 60 पे 90 एंड 180 डिग्री इन एंगल्स पे कैलकुलेट करके मिनिमम 4 to 5 वैल्यूज पे रीडिंग लेने के बाद हम बेसिकली एवरेज कोएफिशिएंट फ्रिक्शन क्या कर सकते हैं कैलकुलेट कर सकते हैं. दिस इज फॉर दिस एक्सपेरिमेंट. Similarly, if any question you have, you can ask me on the Teams. Please let me know. Okay, thank you. This is the experiment we have to go. We went through during the lab session. Hope that's clear. One thing more to counter your answer, like for this is just a check. To approximately check your values, experimental values, कि basically ये जो आपके पास T1 और T2 का difference है T1 minus T2 that's basically 10 Newton and that's 550 grams, so that would be approximately 5.5 Newton. इन दोनों का आप difference करें तो वो 4.54 approximately इस distance के बराबर आता है. तो इसका मतलब है आपका इस वैल्यू के जो कॉर्ड है T कॉर्ड के अप्रॉक्सीमेट आंसर आते हैं. तो इसका मतलब आपकी वैल्यूज़ काफ़ी हद तक एक्यूरेट है. Okay, thank you. This is all about the experiment.